see that here, but you can't see it up here. The brain is making all sorts of assumptions about how Margaret Thatcher should appear upside down, which in fact are not correct. Just like the other systems, all your aspects of the visual world are mapped in fact, multiple visual areas. So this gives you an example of a pattern being seen by a monkey, and you can see exactly the same pattern in its visual cortex at the back of the brain. You can see here these different stripes. Similarly, in a human imaging study here, you can see the different colours located at different points. It's a very modular system, and it works in parallel. It's too complicated to go into, but the point is that you are separately processing form, shape, motion, and texture. And lesions or damage to any part of this system can give you a selective inability to, for example, see colour or to see motion even. For example, a lady pouring out a cup of thermos of tea into a cup. Now, we would see the stream moving. She sees it as frozen. She can't see movement. You can get these highly specific deficits, but they're all modular, but you can interrupt one of them without stopping visual awareness completely. Okay. Also, just to complicate matters still further, we have different systems in the brain for computing what something is that a face, an object of a particular sort, and where it is in visual space. So your what and your where are dealt with by separate parts of your brain. Just to give an idea of complexity further is because that we all have different positions of our eyes. We have forward-facing eyes like most predators do, which gives you a great degree of binocular overlap, which gives you greater visual acuity in your frontal eye fields. But a lot of other species, especially ones that are preyed on, end up with eyes that are more laterally facing. And this, in some cases, the snake here, but also the sheep, for example, ends up with nearly 360-degree vision. Imagine what that must be like. But because there's a trade-off, they actually end up with a smaller amount of their visual field overlapping, where they can really bring things into focus and use their acuity. But it's extremely good in detecting anything around you, far better than our own. The other thing is, I've already mentioned mammals have a lot more of those rods in their eyes than cones than we do. The other thing is that a lot of them have an actual part or feature of their eye called a tapetum, which reflects light back in the eye onto the retina, and that's why their eyes shine in the dark. They have a second bite of the cherry. The light hits the retina, bounces back, and then it gets bounced back again. So that's why they have much better night vision than we do. And in fact, this rod system also allows them to detect movement far better than we do as well.